So in this class we will continue with from where we have left in the last class, okay, in the class immediately ahead of this. So question 25 and 26 important questions we will discuss. First, 25, differentiate between uniform and non-uniform acceleration. Give an example. Now we have seen the example for uniform as well as non-uniform motion in the previous question in the previous class, and we understood it clearly. So let us today give the definition for this. Here the first one, if the velocity of a moving object, okay, of an object means moving, changes by equal amounts in equal intervals of time, it is said to be uniform acceleration. So let us do here example. You can write below this, pause your video and write down this one and then replay it and do this here. Suppose let us say in the first hour you saw a car traveling at a speed of 40 km per hour. Then in the second hour, means as it enters into 1 hour, 1 minute, 2 minutes, into the second hour, it was increased the speed. The car is moving at a higher speed now, 60 km per hour. So from here to here, the increase is 20 km per hour, 60 minus 40, right? So the change here, the change by equal amount. We want to focus here, change by equal amount, right? So here, in the third hour, let us say, we observe the car and it is moving at a speed of 80 km per hour. 80 km per hour. Just keep it simple and follow this. So between these two now, it's 80 minus 20, 60 again. The change is again 20. So it is changing by equal amounts in equal interval of time, means after 1 hour, 1 hour, 1 hour, 1 hour, after equal amount of time, the change is equal. The change is, it is increasing by 20 km per hour, or 20 km per hour. So it is uniform, meaning the change is equal. So this is called acceleration because there is change in speed here, change in velocity or speed. And we know the change in velocity is called acceleration, right? If the car is moving with only one speed, 40 km per hour through the journey, there is zero acceleration. We have discussed that in the previous class, right? So this kind of acceleration is called uniform acceleration because the velocity is increasing by equal amounts, 20 km per hour, 20 km per hour, right? Then the next one, if the velocity, what is non-uniform motion then? So here, in the first hour, let us say, this car is moving with, now you can write the answer according to the example given in the previous question. Right now, for understanding, first hour, let us say, a car is traveling at 40 km per hour. Then after the second hour, it picked up its speed and went to 60 km per hour. Then in the third hour, again, it increased its speed, 60 to 70. So there is change in speed throughout the journey. So this change in speed means there is acceleration. But the change is not equal. See, between these two is 20, and in the next hour, the increase is only 60, 70 minus 60 is 10. So the speed or velocity is changing by unequal amounts after each hour, after equal time. Means first 20, then 10. So when it changes by unequal amounts in equal intervals like this, it is called non-uniform acceleration. Okay, that is the explanation. You can write the example in your previous question instead of using this, but this makes it clear to us. So just before we go to the next question, since acceleration is a very important concept in this chapter, let us see here. Then what is no acceleration? See here, a car is traveling in the first hour. It is traveling at 40 km per hour. Then in the second hour, means as it enters into 1 hour, 1 minute, 2 minutes, like that, then it is still traveling with the same speed. The car is not stationary, it is moving. In the third hour also, throughout, again, there is no change in the speed. Then this is called no acceleration or zero acceleration. So when speed is changed only, that is called acceleration, right? So no acceleration or zero acceleration, but the car is moving. This is uniform motion, uniform speed, uniform motion or uniform speed. So when an object is in uniform movement, uniform speed or uniform motion, there is no acceleration. For acceleration to happen, the speed has to increase, positive acceleration, or the speed has to decrease, negative acceleration. So that is what we need to be very clear about. Again, I repeat, acceleration is simply change in velocity or speed. Change in velocity to be more accurate, okay? Change in velocity. Okay, so we'll go to the next question. The next question is an important question. All are important, but this is especially going to be important to understand so that your concepts are clear. So question number 26. So in this question, we're going to see the distance time graph of uniform speed, okay, uniform speed, or more accurately uniform velocity. So the question there on your tuition note reads, write a brief note on the distance time graph of an object moving with uniform speed or velocity. I've just shortened it to distance time graph for uniform speed or velocity. And then the next two questions, 27 and 28, we will be discussing again distance time graph for non-uniform motion and for stationary object. There are three distance time graph in this chapter in motion, okay? But in this class, we'll discuss only this. Now this will go slow so that we understand very well. It's not hard, but you will need to listen carefully and patiently, okay? So follow me closely and write the same thing as I do, and you'll pick up. Now, let us take an example first. So here, let us say this is distance time graph. So this is the time. This side we take time, and time is in, let us say, minute, and then this side is distance. Let us express in kilometer for this purpose. 1, 2, 3, let us say. That's enough, I think. So let us say in the first 10 minutes, 0 to 10 minutes, a distance of 20 kilometer was covered, okay? And in the next 10 minutes, new 10 minutes, means 10 plus 10, 20 minutes, again 20 was covered. So 20 plus 20 will be 40. Then in the next 10 minutes, so how much will that be? 20 plus 10, yes, that's right. After 30 minutes, it has covered, again, 40 plus 20, 60. So it is like this, covering 20 kilometer in the first 10 minutes, 20, and then also 20. Therefore, 20, 20, 20, so 20, 40, 60. So this type of a car moving in this kind of a fashion is called uniform motion or uniform speed or uniform velocity. So distance time graph for uniform motion, even though we didn't write the question in that format, uniform motion or uniform speed and velocity. How will it turn out if we plot that graph of a, let us say, car in uniform motion or uniform speed? That is uniform speed. You understand, right? So for that, we distance time graph, we write like this. So let's do it here. This side. Please put it here. This we know is called y-axis, right? The vertical line. And the horizontal line on your graph paper is called the x-axis. We know that. So where the two lines meet is called the origin 0, right? Then here, time will be on the x-axis. So this down here is time. I mean this line. It is in minute. Highest is 30. Okay, so let us draw here. 10 minutes, 20 minutes, 30 minutes, like that it goes, okay? Then distance is 60 is highest, so let us say here 10, 20, 30, 40, 50 and 60, okay? Maybe we can just draw it slightly closer so that we can get a clear graph space is there up there for explanation later on. Now here, so maybe here 10, 20 kilometer, 30 kilometer, 40 kilometer, 50 kilometer, and 60 kilometer. So this is clearly on the y-axis we put distance, in this case in kilometer, going in this direction. Time is going in this direction. From here 0 to 10, 20, like that. So we're going to have to plot this diagram. We'll go very slow because this is important for us to understand this. Okay. Now the first is here 10 minutes. After 10 minutes it's covering 20 kilometers. So let us plot that coordinates. So the coordinates on the graph paper will be 10 minutes here. On the x-axis we put time, and on the y-axis we put distance. This is called distance time graph of a moving body. Okay, so here 10 and 20, 10 here and 20. So how do you plot that? 10 is here, so we draw a line 90 degree to x-axis, and 20 means we'll draw a line to 20, 90 degree to y-axis. So this is the point, which is here. We always write this x-axis value first, which is 10 minutes, comma, covering 20 kilometers, so we write here 20. So this is, these two numbers are called coordinates, so 10 and 20. 10 on the x-axis, 20 kilometer on the y-axis, so that point. Now the better is we plot the next 2 points and join it, but since our graph here is not accurate, we won't get it easily, so let us just draw the line first. Join this point to the origin like this, drawing sufficiently long. Not so long, also okay, but sufficiently long. Okay. Then, so this is the first point of plotting coordinate. Then the next is 20, 40, as you can see. So 20 here and 40. So let's do that. And 40. So here we can clearly see that. Wait a minute. 20 and 20 and 40. Manipulate it a little bit, difficult to get accurate, okay? So this is the point. 20 minute on the x-axis, this point, and 40 kilometer on the y-axis. Always the x-axis value we write first, which is here 20, and here 40 on the y-axis. 40 and 20 we write first. 20 here, 0 to 40 here, 40. Next is 30, 60. So here 30 and 60, so we'll write that one. 30 and 60. It doesn't look perfect, but we have to manipulate like that. So if you plot the 3 points for this body in uniform speed, you'll always get a straight line. The graph will always be a straight line passing through the origin. Okay, so this is called the graph of the distance time graph here. This one, this line, is the graph of the body in uniform speed or velocity. So what are its characteristics? Let's start here. Number one is here the distance, write down along with me, time graph is a straight line, inclined towards the x-axis. Let me explain that to you. In other words, that is this, and we will express it. So here, this line is leaning towards, falling down towards x. That's why we're writing inclined towards x. If the graph was like this, for example, I'll just draw a small graph here. If the graph was like this, let's just draw a smaller version of the distance time graph here, 0. Okay, and then here 10, 20, 30, like the minutes, and here distance 10, 20, 30, and the graph was like this. What would you call here? This is the time and this is the distance in short. We also draw below that, okay, explanation. Then we will call this line graph here leaning towards the y-axis. But here this graph is not, this one is not like that, it is leaning towards x-axis. So because of that, you see here, in other words, this leaning towards x-axis means distance is directly proportional to time. So what do we mean by that? Look here. Now let me explain this to you. You write on a new page of your notebook, this one. We want to learn this word today, directly proportional, or simply proportional, directly proportional. So let us take a simple example to understand this meaning of this word, directly proportional. The graph is leaning towards x-axis, which means it is distance is directly proportional to time. How? Let us see. What is the meaning and how? So let us take here a simple case here. This side, numbers of pen, you write like that, multiplied to price, means price of one pen. Then what will you get? We do know that you will get total price. That means, write carefully, because this will really help you to understand directly proportional meaning very well. So suppose you have a pen. I think 3 items is enough, 2 and 3, let us say. So here you bought one pen in a shop of a particular kind and it is rupees 10. Then how much is the total price you have to pay? That's right, rupees 10. Very common sense. Multiply 1 to 10. Right. Now if you buy 2 pens, how much? Price of one pen remains same, right? So 10, so this will be 20. Okay, 20 here. Then here, if 3, common sense also, it is rupees 30. But actually is number of pens multiplied to price of one pen. Here, which quantity is not changing? Only one, right? Yes, that's right. Price of one pen, 10, 10. Never change in all these 3 cases. But what are the things changing? Number of pen is changing, total price is changing. So look here now. One pen, then you pay 10 rupees. 2 pen, rupees 20. 3 pen, 30 means as the number of items pen increase, the total price also increased. As the total number of items decrease from 3 pen 30 rupees to 1 pen going down to 10. So if the relationship of a equation is such that increase of number of pen is 10, 20 like that, increase of number of pen causes increase in total price, decrease in number of pen causes decrease also on the other side, that is called directly proportional. So this graph is directly proportional, means the more the time goes by, the more the distance covered. More time, more distance covered. This is the meaning of directly proportional. So when the graph is like this, it is telling us that leaning towards the x-axis means, as you can see here, as the time is only 10 minutes, distance covered was 20 kilometers. As it increased to 20 minutes, distance covered was 40. So 20 to 40. Then next one here, we forgot to write here, this is 30, right? And 60. As you can see here, 30 and 60. So as the time increased 10 minutes to 20 minutes, distance increased from 20 to 40. And 20 to 30 minutes, then distance increased from 40 to 60. So increase in time is causing increase in distance covered. That is called directly proportional. And that is happening because the graph straight line is leaning towards the x-axis. Okay, so this is called directly proportional. Then what if the graph was, instead of leaning towards x, it is leaning towards y like this? You draw this one below that, okay? Because we want to know what is inversely proportional also. Then this is called, below this you draw this, inversely proportional. Inversely, this type of graph is called inversely proportional. When it is leaning towards x-axis, vertical line, it is called inversely proportional. How we'll see here? You see here. This is not in this question, but we need to know the opposite. That's why we're just discussing. Okay. Now, take a case, a simple case first. A number of girls. Draw that column and time taken. Let us say time taken for them to sweep a classroom. So let us say 5 girls were there and then they took 10 minutes to sweep a one-room classroom. Then let us say you increase the number of girls double, then common sense, they'll take less time because there's more person to do the work. So this kind of relationship, now this is not accurate example, this is a very crude example, okay, but the point here is not accuracy, for us to understand, that's why it's okay. Now here, as the number of girls increase, the time taken is decreasing. Increase in girls, decrease in time. This kind of relationship is called inversely proportional. Increase in number of pens, increase in price. Decrease in number of pens, decrease in price, directly proportional. I hope you got it today, right? So this, if the curve was not leaning towards x-axis, but leaning towards means falling down towards x-axis, like a stick falling towards x-axis, it is inversely proportional. It will be inversely proportional means, you see here, for example, 10 minutes time, 10 minutes, then you draw like this, then this is the one. So this is around 10 minutes, it is covering around 32 kilometers. Then 20 minutes, just take 2 points, you'll understand. At 20 minutes here, it is covering 20 kilometers. So can you see here, as you increase the time from 10 minutes to 20 minutes, distance covered is 32 going down to 20. So distance is decreasing. As time increase, distance decrease. Then this is called inversely proportional. But this is never possible because distance time graph for uniform speed is always straight line leaning towards x, directly proportional. Impossible to be inversely proportional. But if in another case, in another physical quantity, if the graph was sloping down like this, then it is called inversely proportional. Increase on the x-axis will cause decrease on the y-axis value. Okay, I hope you got that. But this is just for understanding. This part, inversely proportional, is not directly applicable to this question. Okay, so first point, as we said, distance time graph of a body in uniform speed is always a straight line leaning towards x-axis, means distance is directly proportional to the time, right? The second point, let's go point by point. The second point, important, okay? Second point is distance time graph of uniform speed or velocity, uniform speed or velocity can be used. This graph can be used to give the speed of the body, speed of the object. Write it down. How? We'll see. So take, for that you take a small part AB of the graph. So let us do that. So let us say we took here. Okay, so we took here a small portion of the graph, A here and B here. Anywhere on the line you can take. You can take AB here also. Just taking here to make it clear to us. So let us say an object was traveling, car was traveling from A to B, like this. Then take any two small on the streams and take any 2 points and make a line segment AB. And from this A lower point, you draw a line from there parallel to the, draw it parallel to the, okay, parallel to the, just draw as long as you want, parallel to the x-axis. So from A, draw a line parallel to x-axis like we did just now. And from B, what will we do? From B, look here. From A, you draw a line parallel to x-axis. Then from B, you draw a line parallel to the y-axis. So this one. Draw a line, I hope you're writing it down, huh? Parallel to y-axis. So very clear now when you do that. So triangle ABC. Okay, so when you do that, what you get is that you can write here these two lines meet at C. Let's say this is the point, they meet here, C, to give triangle, ABC, as you can see here, ABC. ABC. Okay. Now here, after we do this, we're going to, they're saying we can find speed. Now, what is the formula for speed? Speed is distance divided by time, we know that. So we need these two. So here now, what is this? Let us just see here first. Speed is equal to distance by time. So here, let us see this one. This portion BC. Let us check here. This corresponds to, now from B, this is, let it go here. So draw a line again, parallel to the x-axis here. Then this BC is actually this, which is on the distance axis, right? So this is the one. Now let us say this one is S1 and this is S2, meaning this distance here, from here 0 to here, which is around 60, almost 70 kilometer, is S1, 1890. So S2 is around 90. From 0 to here is S2. From 0 to here around 70. 90 is S2, and from 0 to here around 70 is S1. So this here is this one. So S1 is this, right? And S2 is this, and S1 is this. So this portion will be S2 minus S1. So that is the distance covered when the object moved from A to B. Distance covered is this one, because this is the distance axis. So let us write here. Therefore, distance is equal to, given by BC, which is equal to S2 minus S1. You do those things on a diagram, okay? Then how about this? Let us look at this one. Here, this one. A to C. So for that, you draw here. This is already there, but drop a line perpendicular to the x-axis or parallel to the y-axis. So then this portion is here, actually AC. And from here 0 to here is, let us say, T1 time, which is around 40 minutes, and here 50 minutes T2. So this time AC will be 50 minus 40, something like that. So here this will be nothing but T2 minus T1, right? T2 minus T1. So this, we need distance, we found it here, and the time as we move from A to B, the time taken is given by AC, because this is time axis. So time is AC, which is T2 minus T1. Therefore, speed here, let's say given by V is equal to distance by time, we know that. So that means that will be equal to distance here, BC, S2 minus S1 divided by time here, T2 minus T1. T2 minus T1. So with this formula, we can easily calculate the speed of this object by using the help of the small portion of the graph on the straight line graph. So this is the technique by which you find. So distance time graph of a uniform speed or velocity of an object can be used to give the speed of that object by this technique. Okay, this is important. Okay, so that is the as much as you can do. So there is enough. Now you go and read your tuition note question 26, question answer carefully. You will understand very clearly. If no, also you have written it, that is enough. In the next class, 27 and 28, distance time graph again. But that next question will be non-uniform speed. And the last one will be stationary object. Okay, I hope you have understood. Okay.